Good evening, gentlemen. Here we are again. Oh, pardon me, with some of the Kaypro 2 guts. I've done a little bit more reading since the last time we looked at this thing, and I think this is a particularly fascinating machine. So I finally got some SIP headers to fix all of this mangled shit on this RAM drive interface card. But I'm planning on putting a Gotek in this thing anyway, so I'm not entirely sure that we need a RAM disk, and I might put a free HD in it as well. So yeah, I don't know if I need this RAM disk. I may just fix this and then try to trade it to somebody for something a little more interesting. Anyway, so the more interesting part of this is I've got some of the schematics for the Kaypro 4 here, the 484, I think it is, which uses exactly the same main board as the Kaypro 284, but as you can see, there's just some stuff that's not populated. So on the first page we've got the chip layout. Now in the previous video when we looked at this, I think I pointed at this socket when I was talking about the CPU. That was incorrect. The CPU goes in this socket right here. This socket here is for a Z80 PIO, a parallel I/O chip, which is used to interface to a National Semiconductor real-time clock chip in the Kaypro 4. But we'll get to that later on in the schematics. Let's just go through this and see what all we've got here. I'll probably have to reference back to those two pages. So here, this is the schematic of the CPU section. Let me get this where we can look at everything conveniently here. There's that centered. Okay, so there's nothing really super wacky here. The CPU main clock is fed by a 4 MHz signal that's generated on sheet C. We'll look at that later, and it doesn't look well, we'll look at that later. There's an expansion connector on here, this J9 right here. That's the hard drive interface for the Kaypro 10, and all of the stuff for that is populated on this board, I think. But I don't know. I'll have to double check that. But this hard drive interface is actually a general purpose I/O interface to the CPU. Now, from looking at this schematic, it looks like it's only exposing the lower 7 address lines, so that's only going to be good for I/O decoding. There's no way to attach memory to that. Excuse me again, which is kind of unfortunate. I was hoping that maybe we could add some kind of banked RAM scheme to this thing to put like 512K in it and have like a badass Fixery machine going here, but we still might be able to do that using some similar hackery as this thing did plugging into the CPU socket. We'll look at that later. So yeah, that general purpose I/O expansion port, that still might be interesting for attaching other peripherals to it, I/O mapped peripherals, but as far as like memory, that's a no-go, unfortunately. I think that's all I wanted to look at on the CPU sheet. Let's go next. Okay, so here's the video section. I haven't really looked at it much. There's nothing crazy to think about here other than it uses separate horizontal and vertical sync along with a video signal, and I think that the sync rate is compatible with composite video, which leads me to believe that it might be possible to make some kind of board that goes in between the video connector and the video analog board and drive the video board with something else. If we wanted to, say, make some kind of graphics board with FabGL or something, that might be fun. But that's not something to think about right now. This is the same sort of video circuit that we would find in a lot of text-only machines of this era. It just uses a character ROM and a CRTC, and I think this is some kind of custom gate array. I'm not exactly sure what the deal with that is, so yeah, there's nothing on that I want to fart around with too much anyway. So here's the RAM section. Now there's this other custom gate array chip here that appears to be doing all of the interfacing and stuff to this 64K of DRAM down here. So if we were going to add our own banked memory to this, rather than interface to this thing some way to enable and disable the built-in DRAM, I think it would probably be easier, assuming that this gate array doesn't drive anything else, which I don't think it does. It may do some clock generation here, but I think there's maybe, I don't know. Well, anyway, regardless, it might be easier to like maybe lift some pins on this to disable the internal DRAM or the built-in DRAM here, and then we could have like an ASC 6C 4008 or something on a carrier board similar to one of these that plugged into the CPU socket for our banked RAM. So that might be interesting. These are all 1K by 64 DRAMs. So yeah, nothing too crazy there. This is probably doing some clock generation right here. That's a little unfortunate, but we can probably, I'll have to look into that more, assuming we even get that far with it. Some of this other stuff I want to do long before even thinking about that. Okay, so here's the parallel printer and floppy drive controller. There's nothing there to look at. It's got this double density board on it, and this also allows us to use, it multiplexes 2 drive selects into 4, so we can have 4 disk drives attached with this board, as well as accessing using double density drives. So I don't have a schematic for this board. Have to look for it. Haven't gotten around to it. Okay, so here's where stuff gets a little more interesting. This is the serial ports, and these are the 2 Z80 SIO chips. I think they're SIO zeros. It just calls them Z80 SIO on the doohickey thing here. But anyway, so each of these has 2 serial ports built into it, and one serial port is used for the serial printer. Another one is used for the main serial port. Another one is used for the keyboard connector, wherever it went, back here somewhere. I think, yeah, this is it right here. Another one's used for the keyboard connector, and then another one goes to this modem section, which isn't actually populated on this board. So there's a clock generator chip here, this U24, that takes a little bit more than 5 megahertz crystal and generates the baud clocks. It's a programmable clock generator. Generates the baud clocks for these SIO chips. So the one for the serial port, or not the serial port, the one for the keyboard port is hardwired to 300 baud. The one for the unpopulated modem section is also hardwired to that same 300 baud clock source. And then the serial printer and main serial ports use the programmable baud rates. The main serial port has all of the hardware flow control lines connected. The serial printer port does not. However, the unused pins, the unused hardware handshaking signals on this part of the SIO that's used for the serial printer port, they break out to these test points, and those are TTL level signals. But it would be very, very easy to take like a piece of perf board and put like a max 3232 on it, like a serial to RS-232 to TTL line level converter, and attach that to those test points, and then jump those to the serial printer port and have like a real variable baud rate serial port, instead of that dumber serial printer port. Don't have that problem with the regular serial port. It has everything connected how it ought to. So this clock generator can generate up to 9600 baud, I think, maybe 19.2. If it can go to 19.2, it definitely can't go any faster than 19.2. But if you look here on the regular serial port, there's this jumper block right here that attaches to pins 15 and 17 on the serial port. I guess I've been pointing at these serial ports backwards. This is the main serial port, and this is the serial printer port, I guess. But in any case, this allows us to clock the main serial port externally. So it's entirely possible that we could, assuming that the CPU could keep up with it, which at 4 megahertz Z80 probably couldn't keep up with 38400. It would probably have trouble keeping up with 19.2. But if we could get a faster CPU into the thing, which we'll look at here in a little bit, it might be interesting to try to provide an external baud rate generator to that main serial port and be able to run it faster than 9600 baud, because I think the Z80 SIOs can go up to like 56K or something like that. Maybe I'm full of shit there. I know they can go up to at least 38.4. So that would be pretty neat. Now this this modem section, that's in this part of the modem, the actual like analog modem stuff's in this next schematic. But it's here we can see that it's hardwired to 300 baud. Yeah, hardwired to 300 baud. But we could lift a pin on the SIO that goes to this modem section and supply baud rate from somewhere else and run the unused modem half of the SIO at any speed that we wanted. Alright, so if we did that, then if we look at this second sheet where the actual modem ICs plug in here somewhere, RXD, TXD, RTS, and CTS. CTS is on here. CTS is on here somewhere. Those all are broken out in some of these unused IC sockets. So it would be interesting to lift the baud rate pin for the modem section on one of these SIOs and jump onto it and hook the modem SIO to like an ESP8266 Wi-Fi modem, one of these little dealios. Of course, since it's in a metal enclosure, we'd have to cut the antenna and wire it to an external antenna connector or something. But then we could have like a 19.2 or 38.4 4K Wi-Fi modem in this thing, which would be pretty darn handy. And see, we could generate. I don't think the ESP8266 has any hardware PWM pins, but I know the ESP32 does. We could use it instead. It could probably do. The 8266 isn't hardly fast enough to do SSH anyway, so we could use an ESP32 instead. Here's an ESP32, and it does have hardware PWM pins on it, and we could use those to generate the clock rate for the modem side of the SIO instead of having to, tap into one of these, part of the programmable clock generator or something. So that would be, I think that would be cool. I mean, I guess you could just hook it to make something entirely different that hooked to the I/O connector, but that wouldn't be as cool. I mean, we don't want to waste that half of the SIO, right? We can just make a little board with some pins on it that plugs like straight down into these unused sockets, and then this can sit on top, and then we'll have just like a jumper wire that goes to the one pin on the SIO that it has to connect to, and then we'll have a little piece of coax go into a connector in the back for an antenna. I think that would be pretty awesome, even if it's a little more complicated than it needs to be. So anyway, yeah, and then the second half of this schematic is the real-time clock, which interfaces to the bus through a Z80 PIO chip, and I do have some Z80 PIO chips. Is that what the? Yeah, there's a 4 megahertz one. Okay, so I've got two 4 megahertz PIOs. That would be plenty sufficient for a 4 megahertz Z80, and I do have some faster CPUs. There's a 20 megahertz Z80 CPU, and there's a 10 megahertz Z80 CPU. Now, I seriously doubt that even if you tried to drive the CPU like at 10 or 20 megahertz, I doubt that the support logic on the board could run that fast. But the 4 megahertz clock is generated here somewhere. I think maybe it's on. No, that was on sheet C. Hang on a second. The main clock, the 4 megahertz Z80 clock, yeah, references sheet C. So yeah, and this thing must be doing some clock division stuff off of this 16 megahertz crystal Wi-Fi here, and generating the 4, 2, 1, and 4800 hertz clocks. In any case, I think we could probably lift the main clock pin on the CPU and try to drive it a little bit faster, because then the CPU outputs the M1 clock and all of that shit for the rest of the bus, if I am recalling correctly. I may be full of crap. I'll have to reread the documentation. In any case, we may be able to drive it a little faster, like 8 megahertz or something, but I seriously doubt we could get to 10 without replacing some of the support logic on here. It would be interesting to experiment a little bit. I could generate a variable clock with like a microcontroller and feed it into the CPU pin, and we could turn it up and down in real time and see how fast we could drive it before the system got unstable. That might be fun. Assuming we didn't blow something up. Anyway, right, so the RTC. The parallel I/O chip interfaces to the real-time clock chip. It's a MM58167A, which I don't have any of. So I ordered 3 of them off of eBay from a North American seller. Hopefully they won't be fake. And I didn't have this 32.768 kilohertz crystal that the RTC requires, so I had to order a bag of those, but they were really cheap on eBay. And I think I've got the PIO there, and I've got plenty of like random LS series logic if it needs anything else populated, but I think everything's on here. So I think we can populate the real-time clock on here. So anyway, there's the preliminary plan for the Kaypro. I'm very disappointed that only 7 address bits come out on this connector. That's very disappointing. Maybe we can do something about that. I don't know. I need to find some better documentation on that connector. I guess if I'm not going to use this RAM disk, well, it would still be good to make sure that it works before I try to trade it to somebody, because I don't want to send somebody junk. So yeah, let's fix this thing and plug it in and get the thing booting and all of that. I ordered a couple more Gotex off of eBay as well, so those won't be here until the middle of the month though. But we can fix this thing and see if we get like the ROM boot screen when we power the thing on at least. So we got one lifted trace right there while desoldering. The socket it's a very shitty socket. It just came to pieces. I guess the heat's what lifted the trace. All of the contacts pulled out of the board fine. I don't know. Very frustrating. The bent up headers, they came out just fine, very easily. So I think this lifted trace will be easiest to fix on the bottom. I'll solder a fly wire in here with it when I solder the SIP header in there, and then tie it to the CPU socket on the back here. Yeah. To keep everything lined up while I soldered this, I took the old CPU socket that I desoldered from here and I stuck my SIP headers down into it, and there's supposed to be a little bit of a gap right here, right like that, and just a little bit of the top of the pin poking through. That's how the old ones were, so I'll put it back the same way. I'll just solder each corner and then kind of adjust the height till it's just right, and then solder the rest of them. So nothing too big a deal there. I've got my fly wire stuck through there from the bottom, so it'll be soldered in with all of this, and then I'll attach it to the CPU socket here in a little bit. Alright, I think we got it fixed. I got a new socket in there, and I soldered in our new SIP headers. Our little, where'd it go? Our little fly wire there seems to be doing the thing. I still haven't gotten any more brake cleaner, and the only isopropyl I can get around here is 75%, so it leaves this white shit on here. So I'll have to clean that off later sometime, but that should be good enough for testing the thing, I think. I almost forgot about this broken video header here, this J1. We got to get it out of there and fix it. So let's see, the pin 2 is the keyed one. I promised before not to make you watch boring shit, but I guess I am anyway. You'll have to fast forward through it if it's too boring. You've seen everybody on YouTube do this 100 times though, I'm sure. Not so interesting anymore, is it? Two is the keyed one. Yes. get my fabulous roll of tape out, aren't I? I already put all that stuff away. Didn't think we'd need it anymore. There, that ought to work. Well, that's just about straight. Anyway, do a little bit of fiddly-do on it. Yeah, that's plenty good. Good enough for going inside the machine where I won't be able to see it. That'll do, I think. Yeah, it looks fine. That looks fine. Good enough. Good enough. Let's get some of that white shit all over this thing now. Oh well, it'll be back out again. I guess having the residue's better than having the flux on there, isn't it? Ooh woo. What's this? I assume this wire's supposed to go to the other side of the reset switch. I wonder how that came off. Maybe it was off the whole time. This one's about off too. Oh my. Oh my. I guess we better fix that. Well, that's not the prettiest, but I guess it'll do. Alright, I don't see anything else jacked up here. I don't think. Really? So let's see here. Let's try to remember what's what here. This plugs into the doohickey somewhere. This power cable plugs into the side of the motherboard. This plugs into that header that we just fixed. No, it was the Osborne that the power supply for the analog board went through the main board. That's not the case on this one. All right, so I think we're ready to get back together. Maybe, if nothing breaks. Maybe I yanked that loose when I was pulling on these sometime or something. I don't remember that being broken the last time I had this thing apart. I must have just done that more recently. Shame on me. Alright, let's see here. I'm not going to hook up the shush radio. I'm not going to hook up the disk drives or anything. Just the stuff here. Let's see here. Key. These hooks. Like this, I guess. I hope it was number 2 that was supposed to be keyed. Oh yeah, it had to be. Okay, so let's see here. You know what would really, really, really help this thing work is if I actually installed the CPU. That would be some kind of trick, wouldn't it? I think that socket is splooged up. Alright, I think I got the stupid thing in there. Let's switch to shitty phone footage and see what happens. Are you going to live? Oh shit, son. Oh shit, son. We're cooking with kerosene now. This is very exciting. This is very exciting. Alright. Now that thing does not fit in that socket very tight. I presume that the socket was sprunged by the card before, or it was damaged when the card got jacked up. So I think I'm going to have to install a new socket there for the CPU. And I'm not going to, well, if I can get the thing to boot, I really ought to hook up the rest of the RAM disk and test it at some point, because I want to trade it to somebody for something more interesting. But for now, yeah, let's run it without the. Well, no, let's cut it off. Let's remove this thing again. See, it fits in there so loosely. And let's just pull the CPU back out of this card and then see if it'll install a little tighter in that socket. And then we'll just reinstall this card once everything else is working again, just to test the rest of the RAM disk before I trade it to somebody. How's that sound? I think that sounds like a plan, gentlemen. Out you come. Out you come. Out you come. Very good. Let's put this somewhere where I can mash the new pins that I just replaced. Wouldn't that be a trick? This is a really crappy socket. It's one of those old-timey crap sockets. You know what I'm talking about? Oh my god, that thing is loosey-goosey. It's like my ex. Jeez. Let's see if it still boots. It fits a little better than the card did, so I think we're probably good. Yeah, okay, good. Very good. Very good. Very good. Alright. Well, this is excellent. We made some progress. The CRT is very, very sharp and bright. I don't know, let me get the crappy phone camera out again. I don't know if it probably blooms. It probably blooms a lot on the phone. Yeah, it looks way better in person. It looks darker. I mean, the background looks darker, and there's way less bloom looking at it in person. If I turn the brightness down a little bit, yeah, I mean, the individual pixels stand out really well. I don't think there's a tremendous amount of wear on this CRT. So that's pretty cool. That's pretty cool. I can see that I'm going to have to get some cleaner, some deoxide into that contrast knob back there. Well, anyway, yeah, everything's rocking and rolling. I guess I don't want to put everything back together until I have the rest of the stuff to populate that RTC, and I don't know what I want to do with the serial shit yet, and a GoTech. I guess we'll have to get the 3D printer back out and print a 5 1/4 inch faceplate for the GoTech. And the Free HD, the one for the TRS-80, Model 3 and Model 4, it uses the same, it emulates the same hard drive controller that was used in these things, apparently, but it has a different I/O port mapping. But apparently you can get a carrier board that rearranges some of these lines on this 50-pin expansion and burn new GALs for the address decoding on the Free HD, and then run an SD card based hard disk in these things. So I'm going to Tandy Assembly at the end of the month, and I'm hoping, I think Mav's going to be there, and I think he's the guy that's doing the Free HD right now. I've got everything that I need to assemble one. other than the microcontroller and the PC board. I think I've got everything else in my parts boxes. So hopefully I can just get those and save a bunch of money. That'll be exciting. Anyway, excellent. See you all next time. That's all for now.